Hello students, welcome to Learner's Planet, theory session 7 of carbon and its compounds. So till now in our previous sessions we have discussed about the carbon compound structure, the types of chains carbon is forming, and also about the nomenclature of hydrocarbons. The IUPAC nomenclature, we have done it in details, and I hope you would have practiced few more compounds and name them. In this session students, we will be discussing about homologous series and also about the chemical properties of carbon and its compounds. So let's start with it. Now here, what is a homologous series? Now this homologous series is a group of organic compounds having similar structures and similar properties or similar chemical properties. They differ in their physical properties, in which successive compounds differ by CH2 group. Each member of the series is called a homologue. Now I'll give you one example of this. Say if I'm taking homologous series of alkanes, right? So what all members would be there? So let's write the homologous series of alkanes. What all will be the compounds in this series? They will be all alkanes, and they will be arranged in a tabular form. Now this series consists of CH4, that is what students? It is methane. The second member is C2H6. The third member is C3H8. Fourth member would be C4H10. The fifth member would be C5H12. Likewise, your sixth member would be C6H14. Okay, so these compounds are arranged in this homologous series. Now likewise, there is homologous series of every chemical compound or every type of organic compound. Say for example, homologous series of alkynes. What it will contain? The very first member of alkyne is what? It is C2H2. Now what would be its next member? C3, right? So it is what is the general formula of alkynes? It is CnH2n minus 2. So what would be the next member, children? It would be C3H4. What would be the next member? C4H8 minus 2. It will give you 6. 2 4 is 8 and 8 minus 2 will give you 6. So these are the members of homologous series of alkynes. Now what do we find in this? There is a triple bond in each and every member. Where this triple bond is present? It is present between two carbon atoms. Okay. Now in this there is a single bond between the two carbon atoms. Now what happens? That because of the similar bondings, they have similar chemical properties, and also their structures are same, but they vary in their physical properties. Now what are the physical properties? The physical properties are like the molecular weight or the density or boiling points or melting points, right? Now in this they differ because every member has got one more or few more atoms. Now if I check out for the CH4 and C2H6, they are differing by what they are differing, students? They are differing by a CH2 group. So the difference between the compounds or the successive compounds is of CH2. Look here. In methane there is CH4, and in ethane it is C2H6. It means one carbon in H2 has been added. Likewise, in the complete homologous series, the successive members differ by CH2. Okay, so this is a homologous series. Now in this, students, what happens that the compounds are arranged so that they are having their similar chemical properties, but as we move down, the physical properties vary. Okay. Now taking up the characteristics of this homologous series. Now what is the characteristics of this homologous series? All the homologues, that is each member of the homologous series, is called what? Homologue. So all homologues of a series have same general formula. That is, all alkanes have the general formula CnH2n. If I am writing the homologous series for say alcohols, I have written it for alkynes there. Now I'll write the homologous series for alcohols. So what will be the members of this homologous series? The very first member would be, students, it would be CH3OH. The next member would be C2H5OH. The next member would be C3H7OH. The next one, or the fourth member, would be C4H9OH. So the two consecutive members are differing by a CH2 group, right? And now what is the general formula of this? The general formula would be what? It is, I can write it here, CnH, what is it? H2n, right? Plus 1 plus OH. Will it do? No, it should be CnH2n plus O. Okay? So this is not the general formula of alkanes. CH3 is an alkyl, right? So if we have to write the general formula, what is CH3? This is an alkyl. And this is called as of what? Alkyl of what alkane it is? It is alkane of methane. So it would be what? Methyl, right? What would be C2H5OH? What it would be? It would be ethyl. C3H7. What would be C3H7? C3H7 would be propyl. So what are all these, students? These are the alkyls, right? So what will be the general formula of this? Alkyls are denoted by R. May it be methyl, may it be ethyl, or may it be propyl, or butyl, or pentyl, or hexyl. So these are denoted by R. Now what we can write is ROH, right? Or what we can write is CH4O. It is ROH. So what is this point saying? It is saying that the homologues of series have same general formula. Okay? Like alkanes have CnH2n plus 2. Like alcohols have ROH. Like aldehydes have RCHO. Like ketones have got what? RCOR. Now each consecutive member differs from the next by 1 carbon and 2 hydrogen atoms. This I have told you. Okay. Now let's take up few more characteristics of homologous series. Yeah. It is the difference in the molecular mass between two consecutive homologues is 14 atomic mass units. Got it? How it is 14 atomic mass units? The difference between the molecular mass. How it would be? So what I told you was that the consecutive members are differing by what? They are differing by CH2. Okay. So I am writing like CH3CHO. It is what, students? There are 2 carbon atoms. So the root word would be eth, and single bonds, so it would be ane, and aldehydes are named as al, so it would be ethanol. Now what is the next member of the series? The next member of the series would be C2H5CHO. What would be its name? How many carbon atoms are there? 3. What would be the root word? Prop. Okay. Single bonds between the carbon atoms. So N. And what would be the suffix? It is al. Now see the difference between these two. In ethanol, how many carbon atoms are there? 2. How many hydrogen are there? 4. How many oxygen are there? 1. And in propanol, how many carbon atoms are there? 3. Hydrogens. How many hydrogens are there? There are 6 hydrogens. And how many oxygen are there? 1. So, students, what is the difference between the consecutive member of homologous series? It is of a CH2 only. Okay? Now, what will be the difference in their atomic masses? What is the atomic mass of CH2? C is 12, atomic mass of carbon, or we normally write atomic masses as AMU. AMU or atomic mass units. So this is 12 AMU. Now this plus hydrogen, what is the atomic mass of hydrogen? 1. So 2 hydrogen atoms it would be 2. So it is 2 AMU, and now this is equal to 14. So that's what this point is saying, that the difference between the molecular mass of 2 consecutive homologue is 14. Okay, so you can find out this atomic mass unit term everywhere. This can be also written as AMU. Now the next point, the physical properties of homologues show a regular gradation. Now what does this mean? That the physical properties. I told you about the physical properties. What are they? They are the boiling points or the melting points or the density or other properties, right? So in this case, if I talk of boiling points, now what happens? Let's take up our second point. This was our first point. Let's elaborate the second point. Physical properties. Let's take up one property, that is the boiling point. Now what is boiling point, students? Boiling point is a temperature at which liquid starts boiling, right? What does this mean? That the molecules, say I am making this, I'll elaborate this concept to you. Let's take up boiling point here. That is, the second point was the boiling point, right? Now this is, boiling point is what? It is the temperature at which the vapor pressure becomes equal to atmospheric pressure, right? Now don't go deep into this definition. We will do this in say 11th or 12th. Here I just wanted to give you a few example of this boiling point. Say I'm taking this container, okay? Now in this container I'm taking some liquid. Liquid, that is, let's take up water molecules, water only, right? Now in this container, children, there are lots of water molecules, right? So there are large number of water molecules, H2O, 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 okay? Now there is some sort of force between these water molecules which is bonding them together, okay? Now in order to break this force that is in between the two water molecules, there is some force. Right? Now this force is keeping them together. In order to break this force or make vapors out of it, what I'll need is vapor. When vapor will be formed, that is, the molecules are far apart from each other, there is no force of attraction. When I'll get this, when I'll break up this force, how can I break up this force? By giving what? By giving energy or by heating. Okay, so stronger is the force, stronger is the force of attraction between the molecules more is the energy required. Right? So, more is the force, more will be the energy required and more will be its boiling point. Got my point? That is, these vapors go up and then they exert what? They exert pressure on the surface of liquid. And that is your vapor pressure. Okay, now what is happening? That more is the pressure. So these are vapors. Sorry, I have written this spelling wrong. It should be V-A-P-O-U-R. Now these vapors are exerting pressure on the surface. So more is the vapor, more is the vapor pressure. Right? So in order to convert it into vapor, we need more temperature. Now coming back to our compounds. What was this? Say, when I am moving down the group, that is, when I am moving down the homologous series, that is, let's take up the simplest one, that is alkane. Right. So what is the next member of the series? We have got CH4, the next member is C2H6, the next member is C3H. What? 8. Right? The next member is C4H10. Now what is happening? The length of the carbon chain is increasing too. Right? So now as the length of the carbon chain is increasing, what will happen? The force of attraction between them will increase. Got my point? So what is happening here is that the length of the carbon chain is increasing. Length of carbon chain is increasing. Say if I take this butane, what will be the length of its chain? It would be this long, right? Say I can take another molecule also. Say I have got butane solution. So I'll have this long chains aligned together. So as the length of the chain is more, what is happening? The force of attraction is also more. Attraction is more. Right? When the force of attraction is more, what will happen? The boiling point will be high. So what is happening when we are moving along the homologous series? The physical properties increase, that is the boiling point increases and the melting point also increases. Is my point clear? Now in this case, let's take up the third point, that is homologues of a series have similar chemical properties. Now students, the chemical property is decided by what? The functional group. Okay. So when it is decided by the functional group, so it has to be same. In a homologous series, similar elements are arranged, so the properties of the elements would be similar. Let's take up the next point, that is, homologues of a series have similar methods of preparation. Again what? Again we have got the similar functional groups. So their methods of preparation will be also same. Okay. So these are some of the characteristics of homologous series. I hope you understood this. Now let's take up the chemical properties of carbon compounds. Our first property here is combustion. What is combustion? Combustion means the burning of a substance in air. So any substance, when you are burning it in air, it means what? Combustion. Now this is highly exothermic, that is, it produces a lot of heat. How? Say for burning, you just ignite it. After that what happens? Due to the chemical reactions, lot of heat is evolved. So combustion is always an exothermic reaction. Now the products of combustion of carbon and its compounds are carbon dioxide and water. Now let's see few reactions. Example, alkanes burn to produce a lot of heat, due to which they are used as fuels. For example, methane burns with a blue flame in air. That is, what is methane? CH4. It burns in air, this reacts with oxygen and forms what? Carbon dioxide, water vapors, heat and light. Okay. We can take example of another alkane also, like I can take here C2H6. This will also burn in air and it will form what? It will also form CO2, water, heat and light. So this is forming CO2 plus H2O plus heat plus light. Okay, so these burn in air, giving you energy. Since natural gas produces a lot of heat on burning, it is used as fuel in homes and industries. So what is a natural gas composed of? That is again the carbon compound, that is a methane, right? It is a compound with methane and some nitrogen is also there. No, natural gas is composed of methane. Okay. Now this cooking gas, your cooking gas is LPG, that is liquid petroleum gas, which we use in our homes, is mainly an alkane called as butane. So students, this butane is there in your cooking gases, which we are using at home. Now students, this butane, this doesn't have any smell. Okay, so that particular smell which you get from the cylinders, which when it's kept open, is due to the compound or a chemical compound which has been added there to prevent accidents. Okay, so this is again your heat plus light. You must have seen in your burners that there are holes in it. That holes are provided to give oxygen, to provide ample amount of oxygen for oxidation. If the holes are blocked, there won't be sufficient oxidation, and what will happen? The complete combustion will not take place. Okay. Our next point is the saturated hydrocarbons, alkanes, burn in air with a blue non-sooty flame because the percentage of carbon in the saturated hydrocarbons is comparatively low. Saturated means what? There are more amount of hydrogens there. Okay, like your CH4, like your CH2, your CH2 again, CH2 and CH2 and CH3. So here what happens that the percentage of carbon is less. So this gets completely oxidized by oxygen present in the air. Whereas if we are reducing the supply of air or incomplete, then what happens? Incomplete combustion takes place and this produces a sooty flame. Now let's take up the next point, that is this. The unsaturated hydrocarbons burn in air with a yellow sooty flame, producing a black smoke. Why? If you burn oil, it gives that yellow flame. If you burn ghee, that gives yellow flame. Why? Or ghee has got lots of saturated carbon atoms. Oil produces yellow flame. Why? Because it is unsaturated. What do you mean by unsaturated? That is, there are the double bonds or there are the triple bonds. Okay? So in this, what we are finding out, students? We are finding out that there are less number of hydrogen atoms and more number of carbon atoms. So when the number of carbon atoms is more, what happens? It requires lots of oxygen to burn. So if they are burnt in air, air contains less amount of oxygen. So they'll burn with a yellow sooty flame, producing smoke. But students, if they are burnt in oxygen, there will be ample amount of oxygen available to oxidize these carbon atoms. Okay? So they will burn completely. Fine? So that is why your unsaturated hydrocarbons burn with a sooty flame. The unsaturated hydrocarbons here, they burn with a sooty flame. It's the same point, repeated. Alkenes burn with a luminous flame to produce carbon dioxide. Okay. Now there is one more thing which you must have come across, that is cracking or thermal decomposition. In this process, the substances are heated to high temperatures of 500 to 8000 degrees centigrade in the absence of air. Let us say petroleum, we are like heating it, or any long chain compound, long chain hydrocarbon, we are heating it to the very high temperatures, that is a temperature of 500 to 8000 degrees centigrade, and that too in the absence of air. So what happens then? They decompose into a mixture of saturated and unsaturated hydrocarbons and hydrogen. Okay? So what are they doing? They are decomposing into what? Into the mixture of saturated and unsaturated hydrocarbon. Say if I am undergoing the cracking of petroleum, right? That is, if I am heating petroleum or to a very high temperature, if I am heating petroleum to a very high temperature in the absence of air, so what all are the products I can get? I will get, or I can get, alkene, or I can also get a benzene, right? Or I can get a cyclohexane, or I can also get some alkane, right? So they decompose into a mixture of hydrocarbons. It is saturated as well as unsaturated. So this is about the combustion of hydrocarbons. In the next session, students, we will be discussing about few more properties of carbon compounds like oxidation, like their addition reactions, like their, what all reactions are there? Substitution reactions. Okay? So these are few properties. Now, next session I'll be coming with coming to discuss with I'll be discussing about the reactions like substitution, addition and oxidation. Thank you for listening patiently.